Alright, hey guys, so for this video I'm going to show you a little bit about I2C. I wrote a little snippet of code a while back that bit bangs the protocol. If you don't know anything about I2C, it's basically a protocol that's used to communicate serially between a master and any number of slaves using only two pins, as opposed to the many other protocols that can use, depending on what protocol you're using, many more pins. So it's unique in that what you get in advantage in hardware, you kind of have to sacrifice with speed, just because you have to send more bytes along the two lines than you would using, say, SPI, which has a slave select line, obviously. Yeah, so say you're using a module that uses SPI and I2C, you can set it to either or, and you decide to use it for SPI. This little bit bang could be useful if you have extra digital I/O pins that you can set as inputs and outputs, and you can use SPI and I2C. So yeah, let's show the code. I'm going to do a little demo of this IMU that I have from SparkFun. Digital combo board. It has a gyroscope and an accelerometer. I just interface the accelerometer for this. But you guys can look at these data sheets if you want to get this. This thing's pretty useful. It's pretty cheap as far as IMU goes. And you can use it for anything you want to measure the angle on or speed of rotation. So yeah. Okay, so I used the MSP430 on this IAR embedded workbench IDE. Yeah, the MSP430 did from Texas Instruments. I used their Launchpad just because it's only $10 and it's pretty useful. The programmer is built in on it, and MSP430 is pretty useful. Well, they're pretty widely used because they have such good low power features, so it's good to know. The code, the initialization function that I have I called in the beginning just basically sets the clock, sets the P1 lines and UART just to send UART to the computer, and it also sets the P2 out as low. I used port 2 pins 0 and 1 for the SDI and SCL lines respectively. No particular reason. You can use any I/O you want or any pins you want. Doesn't really matter. That's the great thing about this bit bang, or bit banging in general. Yeah, so for the start, if you don't know, remember, we all know I2C. Hopefully this isn't supposed to be really a tutorial on it, just more about bit banging it. I'm going to put this code up on my website, but yeah, so you have to set P2 direction, which is the equivalent, if you're familiar with PICs, of the TRIS register. Basically just sets as input output. And remember, in I2C, the slaves can't actually set the line high. They have pull-up resistors on them, and this combo board has them built in, so it can only set the line low, and it just kind of releases it, and the resistors pull it up high. So really you only have to set the direction of the pin on the master in order to see what's coming in and out, or set what's going out and see what's coming in for this code. Yeah, so here's the start bit. You can look at that. The stop bit right here, the whole function. I'm just setting P2 direction as low and high. Here's the write. So for the write, you just put it in a for loop, do it 8 times, because you already in the write you have to send in the register you want to write to. Go through it 8 times, compare the register character to hex 880, because hex 80 is a 1 followed by 7 zeros, so if this if statement spits out a true, you know that the register's first bit is high, so you set the line high accordingly, and if it's anything else, it's a 0, obviously, and then you set a cycle for the clock it through, and you do that 8 times, and that's the first byte, or the byte that you want to write, controlled by the master. And then you set them both high, and this acknowledge is basically what the slave sends back on the data line, because if it sends a high acknowledge, it usually means the slave is having trouble, and you should stop writing immediately. So it could be useful later down the line. if you run into problems. For the read, you send in a read AC bit. So when you send in a read AC bit of 1, you're saying keep sending data, and if you set it 0, you're saying just want this 1 byte from this register. So you send in another for loop for 8 iterations. You set the SD line as an input, set it high. You have this read register variable, which basically is going to store the data that it sends back in the register you want to write to or read from. So you go through it and you do this P2 direction, set it as a low. This is clock stretching, this little bit of code. Clock stretching basically, if you don't know, allows the slave to hold the clock low if it's busy doing other stuff, and then can set it high or release the clock just to let the master know that it's ready again to receive more information. So this is what this does. You set the clock line as an input, so the master releases the clock, and if the clock line is low, you keep it low. You keep it as an input. If not, then you get out. And that's what basically clock switching does. And if the P2 in SDA line is high, read register basically is reading what the slave is sending back, so that's high. And if it's not, then it's a 0. And you shift it so you can go to the next bit for the top of the for loop. And then you set the direction of the SCL as set it back to low. So you give it back to this master. This is just if the read AC bit that you say is 1, keep the P2 direction as the master acknowledges 1, set the SD line low for more data to be sent by the slave. Yeah, so that lets the slave know on the SD line if it wants to send more. And if not, then the slave will stop and cycle the clock again. So this bit of code just initializes the accelerometer. You need to set the measure bit high in register 2D, and that's all found from the data sheet, and that's what I do. Start, write A6. If I wanted to write, actually let me check. I think, look at the schematic. Yeah, so this is for the gyro. You write D0 for write, D1 for read, and the accelerometer which I'm using is A6, so that's why I wrote an A6 here. And then once I'm within the accelerometer, I write to the register, or I'm letting it know I want to write to the register 2D, and then I write what I'm actually going to write to 2D, and I stop. And this is just to read the accelerometer. You hit start, write to A6. You have to write to an I2C. You have to write first in order to read. Write to the register 32, so the slave knows that you want to read from 32. Set another start bit, and then you send the read, and then you go to the read function. I'm just reading 1 byte at a time. And then in the main loop, I do all the initializations, and then in the while loop I just do read, and then write it to the UART buffer so we can read what byte it gets back, and then do a little pause. So yeah, that's pretty much it. And like I said, I'm going to put this on a link in the bottom of the video to check out this code. So yeah, hopefully this is helpful for you. And I'm going to just do a little demo for it. You're going to have to take my word for it that I am, let me program it first. Yeah, you're going to have to take my word for it that I am changing the accelerometer because I set up a camera to prove that I'm moving it to change the values, but oh well, you have to trust me. So yeah, you can see I'm keeping it flat, and it's a pretty low value. They're mostly zeros. It's hard to read pretty fast. But if I shift it, I'm shifting it now, see it's going higher. And as I go more vertical, see it's going to F and then it goes to 0. That's because this is a 10-bit accelerometer, so as I get to FF, it goes back to 02 because a byte's only 8 bits. So it's obviously, here, I can show it. Here I had this F values, and it kept switching between F and 0 when it was completely 90 degrees. That's basically just because it's a 10-bit value, so when it goes to FF and it goes above 8 bits. The other 2 bits that I didn't read, because that's in register 33 instead of 32, those get filled with 1 through 0 through F, while the last 8 bits get filled with mostly zeros because it's a higher value. So yeah, that's pretty much I2C. I'll put some links down in the video to help you if you need help with I2C. You don't know too much about it. There's some useful stuff on the internet about it. And hope you guys like the video.